Okay, next is gonna be the stresses in helical tension spring anyway. So this type of spring is typically gonna do a lot with the types of spring is gonna be in the balance in terms of lift, in terms of elevator, things like that. I'm not gonna do this with the examinations anyway. It's gonna be very straightforward, but we're gonna aware a lot with the fatigue design, okay, with the hooks right there at the top and bottom, things like that. And the calculation is pretty much straightforward. It's about the same things that what we have done before, okay. So that's why this topic I'm gonna skip it, okay, as these in terms of examinations anyway. And then that what we gonna do on it is gonna be the terms of the uh, terms of this kind of spring. Okay, you may figure out exactly the same that what we have done before with the compressive spring. Okay, the things that what different is going to be, we have the terms of F sub y. We're going to have the initial tension force to be exerted on the beginning rather than we're going to put it as the F minus F sub 1 first. Okay, so it's why exactly the same than what we have done before. And then we're going to add up some more forces, 80%, corresponding to the things that what we've done before as the terms of the design. We have an example of 10.3. So next year you guys gonna do some kind of like this kind of spring. You can look it up by yourself, okay, for this kind of spring. And 10.4 for the load gonna be changed in time or fatigue design, things like that, okay. And then for the section 10 for the helical torsion spring also, okay, this type of spring for the type of spring is gonna generate with the sigma that what the spring gonna face some kind of like stresses induced in springs, things like that, and the zeta, which is going to be the twist angle in the spring. We're going to have a K term, stiffness of this K term. I have an example and what one of my design on the spring term. We're going to have some kind of twist angle on that. It's pretty much straightforward. You're going to have a look at by yourself. This type of spring we can pretty much straightforward an example for you guys to have a look at for yourself for the next year for the your senior project. And then for the leaf spring also, okay, this is kind of leaf spring is going to be a spring that can be able to exert a huge numbers of K or stiffness the springs anyway. The spring is going to look like in a figure P there. We're going to have this type of the wheel, okay, just attached to be here, and the force of the wheels are going to be applied on that, and then the number of leaves is going to be 1, 2, 3, and 4, things like that, and then uh, it's just going to be equivalent to the cantilever beams look like that, okay, and then we kind of design, and then the springs going to be look like a leaf, look like that, okay, and then since it's going to be cantilever beam look like that, so therefore the calculation is going to be a cantilever beam of sigma is equal to this type of equation, okay. We're going to have example look like that. This one I also gonna skip it because that's why you guys gonna study more in automotive engineering and things like that. This type of spring we will also call it a semi-elliptic leaf spring, things like that. Okay, this is 10.6 example. You may have a look at it. Okay, by yourself, things like that. I would like you guys to have a look at the problem number 1. Okay, next year you guys gonna have some kind of like experiences. Okay, at the coin spring. This coin spring, you can take a measurement and make a calculation by yourself. Okay, you can take a measurement on the diameter of the spring rod by yourself. It's going to be 3.4 on the diameter, and the mean diameter and the free length, things like that. And you make a calculation of everything of the spring rod here of the compressive coin spring. Okay, you're going to practice by yourself on the example number 1 there. And then the number four, you can have practice by yourself, things like that. Okay. And then, okay, this is gonna be the spring. That's what I would like to make a lecture on these kind of things. Okay, so that's why I would like to end up my lecture for today. Anyway, thank you very much. Okay.